Huh. Got like a little bit more light. Now it looks like I have a hazy light behind me. Anyway, second video is on dividing rational expressions. And we're just going to spend a little bit of time on this because dividing fractions is actually the second easiest thing that you can do with fractions because it's like multiplication with one leading step in there. So I want you to remember this idea. Dividing is just multiplying. This is the actual definition of division. It's multiplying by the reciprocal. Okay, that's what dividing is. And here's what we mean by that. So if you have one fraction and it is divided by another fraction, that is simply the first fraction. And instead of dividing, you are actually multiplying by the reciprocal. And remember from a couple lessons ago, a reciprocal is just the fraction flipped over. That's literally what division is. And so dividing rational expressions really isn't any harder than multiplying because all you're going to do is take the second fraction, flip it, and now it's a multiplication problem. So I'll give you some examples with numbers. So if you had 3/4 divided by 1/2, that's actually the same as 3/4 times 2/1. And you'll see stuff online sometimes, like people will try to trick you, like divide it by 1/2. The phrasing, it can be a little tricky there. So you're dividing by 1/2 means that what you're dividing by is the number 1/2, which is different from dividing something in half. So I have a pizza and I divide it in half, is phrased a little bit differently. So those words matter. Like, am I dividing it by 1/2 or am I dividing something in half? Because dividing it in half means to divide by a 2. The same thing. So yeah, so we've got that. And now that's just a multiplication problem. So you would have 6/4. And then you would recognize that you could simplify that into, what do we simplify that into? 3/2. Now, as before, what is usually easier to do, though, because it typically will save us time, is to factor it first. And so you would say, oh, well, the 4 is 2 times 2. And then you would cancel that out. And now you can see easier, oh, I have a 3 left on the top, and then 2 times 1 is just 2. And you don't need to figure out how to simplify it after the fact. So really, dividing is just, you're going to flip the second fraction because that's what division is. And then it's a multiplication problem. So it's exactly like what we just did, where we would factor and then cancel out those factors and simplify it from there. And one of the reasons I am going through this is to really review factoring. I know factoring is everybody's favorite thing to do from the fall, but and you don't need me to motivate you. Go factor. All right, but it is worth reviewing, and so we're getting a healthy review of factoring, and it's about to get cooler here because look at this. Look at that. Let me finish writing this and we will, what are we going to have here? X plus 1, and this is going to be x squared plus 7x plus 10. All right. Okay, so right here, we're reviewing like a different kind of factoring. That is the sum of 2 cubes right there. That is the sum of 2 cubes. And that is factored with the soap sandwich. So it's been a long time. We did soap sandwiches back end of November, early December, maybe mid-December. I don't really remember. It was a long time ago. And we really have not looked at them since, except maybe in a multiple choice question somewhere. So it's good review. So the first thing I'm going to do with this, though, is I am going to go ahead and flip that second fraction over. So to divide by that messy, nasty looking fraction there, is the same as to multiply by the reciprocal. Now, what a lot of people will do is they will factor in this step. So they will flip it and factor it at the same time. And that is totally okay to do. So what do we notice? We've got some stuff going on here. First thing I notice is that I cannot factor those x plus 1s. In fact, those x plus 1s are going to cancel. So I've got an x plus 1 in a numerator and an x plus 1 in a denominator, and they will cancel. I won't cancel them right at this second. We will get the rest of it factored. Now let's see. I typically, when I've taught this in a lot more detail, I would tell students, go find what you think is the easiest factoring problem and start with that, because you're expecting stuff to cancel. So it'll give you a hint. I think the quadratic, we'll just pretend that we don't remember how to factor the sum of cubes. So we got the x squared plus the 7x plus 10. So we're going to do that one. And I want two factors of 10 that add up to 7, and that would be 2x and 5x. And so x factors into x squared, factors into x times x. We have a 2x, we have a 5x, and so that would give me x plus 2 and x plus 5, but not there. So don't write it there. Go me. Here we go, x plus 2 and x plus 5. There we go. Okay, and that now leaves us with the other factoring. Pause if you need to write that down. So that leaves us with the sum of two cubes, okay? And so we'll take a moment to review our SOAP sandwich. So a sum of cubes has a small parenthesis and then a larger parenthesis, and the SOAP means same, opposite, always positive. And so the SOAP is a little acronym that helps us remember what the operators are. Now you can probably use the existing problem to help you out. So we want to get good at this. Like, how can I use one part of the problem to help me with another part? I'm expecting something down here to cancel with something up here. So I'm expecting to see either an x plus 2 or an x plus 5. Well, there is no way I'm getting a 5 out of the 8 there. So probably we are going to see an x plus 2, which means that this factor right here would need to be the x plus 2. And it is. So to get that factor, you simply take the cube root of the x cubed and the 8. So what cubed gives you x to the third? That would be x. What cubed gives you 8? That would be 2. And then to get the other parenthesis, we make our sandwich. We square it, smush it together. So think about the loaves of slices of bread are kind of like squares, okay? Square it, smush it together. And by smush it together, we just mean multiply. So I'm going to square the x to get x squared. I'm going to square the 2 to get 4, and then I'm going to do x times 2 to get the middle, which would be 2x. So we've got a nice review of the sum and difference of cubes. If you are a senior this year and you are taking your exam very early, this is probably your review. All right, so now let's cancel our common factors. So I have an x plus 1 in the numerator, which can be canceled with an x plus 1 in the denominator. Notice that we're not canceling the terms. We're not canceling just an x by itself. We're canceling the entire unit. I have an x plus 2 that can be canceled with another x plus 2, and that leaves me with my answer, which will be x plus 5 over x squared minus 2x plus 4. And that is how you divide rational expressions.